Hi guys, welcome to today's tutorial. Today we'll be treating Math 101 general questions. Our first question says if log 2p equals x and log 4q equals y, 1. We should express each of p squared q and p over q squared as a power of 2, and 2, given that p squared q equals 16 and p over q squared equals 1 over 32, that we should find the value of x and y. All right, in solving this, we can have this as, since our log 2p is already in base 2, so this will become our equation 1. So we need to convert log 4q y to base 2 also. All right, to put them in common base. Now, in changing this, we'll first of all apply our change of base law to this, which will give us, this will now give us log 2q, since that's what we want, all over log 2, 4. Now, bearing in mind that our 4 is 2 raised to the power 2, all right? So we'll now apply that here. This will equals y. This will be having as log 2q all over log 2 raised to the power 2 equals y. All right, from here, we can bring down our power down to give us log 2q all over 2 log 2 equals y. And we know in our law of logarithm, if we have log AA is equals to 1. So now, in this case, we are having log 2, which will give us 1. So this will now become log 2q all over 2. This log 2 will turn to 1 times 1 equals y. So this will lead us to log 2q all over 2 equals y. So from here, log 2q will give us 2y. Okay, cross multiplying 2 times y will give us 2y. Now this will be our equation 2, while our log 2p equals x is our equation 1. Now, back to the question where we say express each as a power of 2. Okay, now for us to express each of these as a power of 2, from equation 1, we have log 2p equals x. Now, for us to do this, we will be equating from our question. It says make p squared q as base in the as a power of 2. So now our p is going to be log 2p. So this will give us log 2p squared q. All right. Now from here, we can separate this log to give us log 2p squared plus log 2q, since it's multiplying. All right. Now we know that our log 2p is x. Okay. So bringing down this gives us 2 log 2p plus log 2q. Okay. So from here, we know that our value of log 2p is x. So this will become 2x plus our value of log 2q is 2y. So in the powers of 2, this will become 2 raised to the power 2x plus 2y. All right. Now this is let's call this equation 3. All right. Having this as our equation 3, our next one says p over q squared as a power of 2. All right. From here, we know that this will give us log 2p over q squared. Now separating them, we know that in our power of log, division is subtraction. So this becomes log 2p minus log 2q squared. Okay. Now, from here, our log 2p is x, so this will give us x minus, okay, before this we have it as log 2p minus 2 log 2q. Okay, so from here we have our log 2p as x and minus our log 2q as 2y. So this gives us 2 brackets 2y. So for here we'll be having it as x minus 4y. So in the powers of 2, this will give us 2 raised to power x minus 4y. Now, that's for question 1. Now for question 2, it says, given that p squared q equals 16 and p over q squared equals 1 over 32, that we should find the values of x and y. Now, in order to do this, our p squared q from here, is this value. Okay, so this becomes 2x plus 2y equals 16. Now, if we break 16 down, okay, 16 would be 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So this is 2 raised to power 4. All right? So this will have as 2 raised to power 2x plus 2y equals 2 raised to power 4. Okay, now from here we can equate our bases. This, we cancel this, leaving us with 2x plus 2y equals 4. Okay, now dividing both terms, we have it as x plus y equals 2. Let's call this equation, okay, this should be our equation 4. So this will be equation 5. Now, to the second aspect, where we have p over q squared equals 1 over 32. All right, now we know that p plus q squared, the value gives us this. So this will become 2x raised to power x minus 4y equals 1 over 32. Now we're writing these fractional indices as a whole number. We have it as 2x minus 4y equals 32 minus 1. Okay, now breaking our 32 down to the powers of 2, this becomes 2 times 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. That is 2 raised to power 5. So this gives us 2x minus 4y equals 32. 2 raised to power 5 times 1 minus 5. All right, now we can equate our bases. So this we will be having as x minus 4y equals minus 5, equation 6. Now bringing our equation 5 and 6 together, we have it as x plus y equals 2 and x minus 4y equals minus 5. So from here, we can do our simultaneous equation. Now, since our x has same coefficient of 1, we can now subtract. X minus x will cancel out, giving us 0. Now, minus times minus will turn to plus. 4 plus 1 will give us 5y equals minus times minus will turn to plus. 5 plus 2 will give us 7. So, therefore, y equals 7 over 5. Now, knowing that our y equals 7 over 5, we can now find x plus y equals 2 from equation 5. All right, our x plus y equals 2. Now, we know the value of y. This will give us x equals 2 minus y for the value of x. So, x equals 2 minus 7 over 5, which is our value of y. Now, this is 2 over 1. Finding our LCM here, x would be 5. Now, 1 into 5, 5. 5 times 2, 10. Minus 5 into 5, 1. 5 times 7, 1 times 7, 7. This gives us 10 minus 7, 3 over 5. So the value of x is 3 over 5, and the value of y is 7 over 5. Our B part of the question says solve the equation. We have 3 raised to the power minus 2 bracket 3 2 raised to the power 2x plus 1 plus 26 bracket 3 raised to the power x equals 1. Now, first off, we convert this to our proper fraction, removing our minus. This becomes 1 over 3 squared bracket 3 2x plus 1 plus 26 bracket 3 raised to the power x all equals to 1. Now this will give us 1 over 9 bracket 3 2x plus 1 plus 26 bracket 3x all equals 1. Now since this is multiplying everything in the bracket, we can put it as 1 as 3 raised to the power 2x plus 1 plus 26 bracket 3 raised to the power x all over 9 equals 1. So from here we cross multiply. If we cross multiply, this becomes 3 raised to the power 2x plus 1 plus 26 bracket 3 raised to the power x equals 9. Okay, now at this point we can say expanding this will give us 3 raised to the power 2x times 3 raised to the power 1, okay, plus 26 raised to the power 3x equals 9. So from here, let's say let 3 raised to the power x equals y, okay. Having it as this, we can now say since this is 3 raised to the power x, this will give us 3 raised to the power, okay, we can say this, our 3 raised to the power 2x would be our y raised to the power 2. Okay, this is 3 raised to the power 1. Then our 3 raised to the power x will be y. So imputing this here, this becomes 3 times y raised to the power 2, which will give us 3y squared, plus 26 times y will give us 26y equals 9. Now moving this over here, this becomes 3y squared plus 26y minus 9 equals 0. Now from here, we'll solve out our quadratic equation. Now we have a equals 3, b equals 26, and c equals minus 9. Using our quadratic formula that says x equals minus b plus minus root b squared minus 4ac all over 2a. All right, now in this case, our x, the value, our x is our y, so we can replace this with our y equals this. So our b will become, y will become minus 26 plus minus b root 26 squared minus 4 times 3 times minus 9 all over 2 times 3. So our y equals minus 26 plus minus root 26. 26 squared would give us 676. Now minus times minus is plus, so this will become 12 times 9 will give us plus 108. All right, all over 2 times 3 will give us 6. So our y will become minus 26 plus minus root. This will give us 108 plus 676 would give us 784. Okay, all over 6. And we know that this will be minus 26 plus minus our root 7, square root of 784 will be 28 divided by 6. So this becomes y equals minus 26 plus minus plus 28 over 6, or minus 26 minus 28 over 6. So our y would be 2 over 6, or this and this will give us minus 54 over 6. Now, the value of our y would be 1 over 3 or minus 9. Okay, now at this point, we have our value of y to be minus 3 or minus 1 over 3 or minus 9. Recall that y equals 3 raised to power x, and our value for y is 1 over 3 and minus 9. So for this, we have 1 over 3 equals 3 raised to power x. Now, changing this becomes 3 raised to power minus 1 equals 3 raised to power x. So equating our basis, x will give us minus 1. All right. Now, looking at the other one where we have y equals minus 9, this will become minus 9 equals 3 raised to power x. All right. So this will be 3 minus 3 raised to power 3 equals 3 raised to power x. Now, this would not be valid since both bases are not equal. So our right answer will become x equals 1 minus 1. Solve the simultaneous equation. 9 raised to power x equals 27 raised to power y, and 64 raised to power xy equals 512 raised to power x plus 1. Now, from here, our first question is 9 raised to power x, which can be broken down to 3 raised to power 2 times x, which will give us 2x, and 27 raised to power y can be broken down to give us 3 raised to power 3 times y, which is 3y. Now, substituting this for this will give us 3 raised to power 2x equals 3 raised to power 3y. Cancelling this, 2x equals 3y. So from here, we can call this x equals 3y over 2. Let's have this as equation 1. Okay, now back to the second question where we have 64 raised to power xy. Okay, now I'm breaking down 64. This will give us 2 raised to power 2 times 2 times 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, 64. So this will give us 2 raised to power 6 xy. Okay. Now for 512 raised to power x plus 1 will give us 2 raised to power 9 bracket x plus 1. All right. Now substituting this for this our values here, this will become 2 raised to power 6 xy equals 2 raised to power 9 x plus 9. Okay, expanding this bracket, 9 times x will give us 9x, 9 times 1 will give us 9. Now, equating our basis, we will have it as 6xy equals 9x plus 9. Let's call this equation 2. Now, from here, substituting our value of x in equation 1 into equation 2, we would have it as 6 times 6 over 1 times 3y over 2 times y over 1 equals 9 times 3y over 2 plus 9 over 1. Okay, so from here, 2 we cancel. 2 into 2, 1. 2 into 6, 3. 3 times 3 would give us 9y squared equals, this will give us 27y, 9 times 3, 27y over 2 plus 9 over 1. Now, our LCM for this side would give us 2, okay? 2 into 2, 1. So this will give us 27y plus 1 into 2, 2. 2 times 9, 18. Okay, so cross multiplying, 9 times 2 will give us 18y squared equals 27y plus 18. Now, moving all our terms over to the other side to equate it to 0, this becomes 18y squared minus 27y plus 18 equals 0. Now, with this, we have a quadratic equation. We can decide to break this down using 9. So divide through by 9, divide through by 9. This will come 18 divided by 9 will give us 2y squared minus 27 divided by 9 will give us 3y plus 18 divided by 9 will give us, sorry, this should be minus, will give us minus 2 equals 0. All right, now with this, we can apply our formula that says y equals minus b plus minus b squared, minus b plus minus root b squared minus 4ac all over 2a, which is the quadratic formula. Now, in this case, our a is 2, which is the coefficient of y squared. Our b is minus 3, which is the coefficient of y. And our c is minus 2, which is a constant. Now, applying this into our equation, y equals minus b minus 3 plus minus 3 squared minus 4 times 2 times minus 2 all over 2 times minus 2 times 2. All right, so this gives us y equals 3 plus minus root 9. 4 times 2, 8. 8 times 2, 16 plus 16 all over 4. So from here, we can see that our answer will become 3 plus minus root 25 all over 4. So this leaves us with y equals 3 plus minus 5 over 4. Okay, now expanding this, we are having it as 3 plus 5 over 4 or 3 minus 5 over 4, which leaves us with y equals 8 over 4 will give us 2, or minus 3 minus 5 will give us minus 2, so that will give us minus 1 over 2. So the value of y will become minus 1 over 2, or 8 divided by 4 will give us 2. Now, substituting, recall that our x equals 3y over 2. All right, so substituting when y is 2, when y equals 2, x will be 3 brackets 2 over 2, which will give us 3 times 2, 6 over 2, which will give us 3. So, and when y is minus 1 over 2, this leaves us with x equals 3 times minus 1 over 2 all over 2. Okay, so this will give us my x equals minus 3 over 2 times 1 over 2. Okay, so this will leave us with minus 3 over 4. So values of x will be 3 and minus 3 over 4, and values of y will be 2 and minus 1 over 2. So this gives us the value for x and y. Find the values of x that satisfies 3x all over, sorry, this should be 3 and this should be 2. So 3 all over x minus 2 greater than or equals to 2 over 1 minus x. Okay, now for us to solve this, we have two equations here. Okay, let's bring our x forward. In making our x, we have x minus 2, okay, equals 0, equating it to 0 for our numerators, equating it to 0. X minus 2 equals 0. So therefore, our x equals 2. And Secondly, 1 minus x equals 0. Okay, so this becomes x will become x equals x will equal minus 1. Okay, so x will be x going over will give us a positive 1. So x equals 1. So from here, we know that we have 2 points of x equals 1 and x equals 2. All right, now solving out this, we have 3 over x minus 2 greater than or equals to 2 over 1 minus x. Now cross multiplying, this will give us 3 bracket 1 minus x and 2 bracket x minus 2. Okay, now this will have 3 minus 3x and 2x minus 4. Now collecting like terms, this we are having as minus 3x minus 2 minus 3x minus 2. Okay, let's keep it positive and have it as 3 plus 4 and 2x plus 3x. Okay, so this will give us 7 is greater than or equals to 5x. So our x will become 7 over 5. Okay, so our x will be less than or equals to 7 over 5. So the values of x that satisfies the equation would be x equals 1, 7 over 5, and 2. So these are the 3 values that satisfies the equation. Find the range of values of p for which the equation x squared plus 2px plus 4p minus 3 equals 0 has 2 equal roots. Now, in order to do this, we are asked to find the determinant, and the determinant of this equation is given by b squared minus 4ac. Okay, if we have it as b squared minus 4ac, for us to find the determinants of this, which are the 2 equal roots. Now, our a here is 1. Okay, our b here is 2p, and our c is 4p minus 3, which acts as our constant. Now, substituting into this will give us b squared will be 2p squared minus 4 times 1 times c is 4p minus 3. Okay, so this will, opening up our brackets, this will give us 4p squared minus 4 bracket 4p minus 3. Okay, expanding this we will be having 4p squared minus 16p plus 12 equals 0. Now, this gives us a quadratic equation. Now, having our 4p squared minus 16p plus 12 equals 0, we can divide through with 4. All right, to reduce this. This will give us p squared minus 4p plus 3 equals 0. Now, factorizing this we are having as 3p squared. Now, factors of 3 that will give us minus 4. We'll have it as minus 3 and minus 1. Now, minus 3 times minus 1 will give us a positive 3. Minus 3 plus minus 1 will give us a minus 4. So this we have. Now, replacing this for this, we have it as p squared minus 3p minus p plus 3 equals 0. Grouping these two together, we have p, which is common here, p minus 3, and minus 1, which is common here, p minus 3 equals 0. So p minus 3 equals 0, so therefore p equals 3, and p minus 1 equals 0, so therefore p equals 1. So the value of P that has two equal roots will be 1 and 3. If cos alpha equals 3 over 5, where alpha ranges between 0 to 90 degrees, and cos beta equals 12 over 13, where beta ranges between 270 and to 360 degrees. Now that we should find A, cos sine alpha, B, sine beta, and cos alpha plus beta. Now, it is important to note that if we have a quadrant, now we have our first quadrant, second quadrant, third quadrant, and fourth quadrant. Now, this in the first quadrant, all our sine, cosine, and tangent are positive. In the second quadrant, only sine is positive. Now, cos and tan are negative. Now, in the third quadrant, only tan is positive. Sine and cos is negative. Now, and in the fourth quadrant, only cos is positive. Sine and tangent are negative. Now, for this, our first quadrant ranges between 0 to 90 degrees. So, second quadrant, 90 to 180. Third quadrant, 180 to 270. And fourth quadrant, 270 to 360 degrees. Now, it is important also to know that this lies within the first quadrant. So, all are positive. Okay? Now, in this lies within our fourth quadrant. Now, in this, cosine is positive, our cosine is positive, sine and tangent are negative. All right, now we'll bear this in mind. Now, for this, it says, let's look at our Pythagoras theorem. Using our Pythagoras theorem, where we have cosine equals adjacent over hypotenuse. Now, our adjacent, calling this our alpha, our adjacent will become 3 over 5. So our adjacent will be 3 and the hypotenuse is 5. So for us to find this, our opposite, which is sine equals opposite over hypotenuse. So for us to find sine, okay, this becomes hypotenuse squared, Pythagoras rule, equals opposite squared plus adjacent squared. So our opposites would be square root of hypotenuse squared minus adjacent squared. Now our opposite would give us hypotenuse is 5 squared minus 3 squared. So opposite would give us root 25 minus 9, which will give us root 16, which will be 4. So our opposite will be 4. So now, to our sine alpha will be 4 over hypotenuse 5. Since it's in the first quadrant, since alpha is in the first quadrant, it will be positive. Now, to the other part that says we have our cos beta. All right, bearing also in mind that cos beta is adjacent over hypotenuse. Our hypotenuse will be 13 and our adjacent will be 12. Okay, for us to get our opposite, that will become opposite, which is root hypotenuse squared minus adjacent squared. This gives us opposite would be 13 squared minus 12 squared, and 13 squared is 169 minus 144. Okay, so our opposite will be square root of 25, which will give us 5. Okay, so our sine beta will become 5 over, which is opposite over hypotenuse, 5 over 13. But now, Since it's in the fourth quadrant, our sign will be negative. So our sign beta will become minus 5 over 13. Now that will give us our sign beta. Now, for us to find cos alpha plus beta, all right, this will use our trigonometric identity, which will give us cos alpha cos beta minus sine alpha sine beta. Now, our cos alpha is 3 over 5 times cos beta, which is 12 over 13, minus sine alpha, which is minus, sine alpha is 4 over 5, times sine beta, which is minus 5 over 13. Okay, now we can see we have a common denominator. This will give us 5 times 3 times 12 will give us 36 over 65 minus 20 over 65. Minus times minus will turn to plus. So this gives us 36 over 65 plus 20 over 65. Common denominator will be 65. 36 plus 20 will give us 56. So our alpha, cos alpha plus beta, will be 56 over 65. Find the domain of the two functions. We have our question 1, f of x equals 12x plus 3 all over x squared plus 2x minus 3. Sorry, this should be minus, not plus. Now, it is also important to remember that for our domain, for us to find the domain of this function, it will be all real numbers except the roots of our denominator of our equation. So finding the roots of the equation, we're having it as x squared plus 2x minus 3. Okay, factorizing will give us minus 3x squared. So this will give us 3x and 1x. Okay, so minus, so this will become 3 times minus 1 will give us minus 3. 3 plus minus 1 will give us a positive 2. So substituting into this equation, we have it as x squared plus 3x minus 1x minus 3. Okay, grouping these two together and these two together equals 0. We have common here is x plus 3. Common here is 1 minus 1, x plus 3, okay, equals 0. So we have x plus 3 equals 0, which will give us x equals minus 3, and x minus 1 equals 0, which gives us x equals 1. So for our x, for our domain for this first function would be all real values, okay, except minus 3, and 1. Okay, for all real values, except minus 3 and 1. Now, for our second function, it says g of x equals root x plus 4 all over x minus 2. Now, for us to find the domain of this function, it is for us to find the values of x under this square root that would define our expression. 1, the values of x that defines the expression, and 2, the values of x that are non-negative. Now, these two will help us find the domain of our equation. Now, for this, we are having it as x, for the numerator, x plus 4 equals 0. So therefore, x equals minus 4, and x minus 2 equals 0. So therefore, x equals 2. Okay, now let's test our hypothesis. Now, if we say our x plus 4 over x minus 2 equals 0. Okay, now at those points, we can see that if we say when x is minus 3, okay, our minus 3 will be minus 3 plus 4 all over minus 3 minus 2, which will give us minus 1 all over minus 5, which gives us 1 over 5. Okay, so this satisfies our equation by saying it is a non-negative value. And also, when we have, this will be plus 1. 4 minus 3 will be plus 1. So this will give us a minus, which does not satisfy, which will make it negative, minus. So this does not satisfy. So, but when we look at when x is, this is when x is minus 3. So when x is minus 5, which is greater than our minus 4, which is less than our minus 4, this gives us minus 5 plus 4 all over minus 3 minus 2, which will have us minus 1 over minus 5 over 2, which will give us minus 1 over minus 7. Minus cancelling minus gives us a positive. This satisfies our equation. It defines the expression and is non-negative. So when x is 0, okay, 0 plus 4 all over 0 minus 2 will give us a 4 over minus 2, which is the minus 2. This does not satisfy our expression. And also, when we look at when x is, since it's greater than 2, is 3, this will become 3 plus 4 all over 3 minus 2, which is 7 over 1, which will give us 7, which is non-negative and defines the expression. So we can say that for our domain, it ranges from, negative infinity and minus 4 to minus to our 1 and infinity. So our 3 and infinity, this 3 and infinity. So this covers our domain. With this, we've come to the end of today's tutorial. If there be any comments or questions, put them down in the comment section below. Don't forget to like, subscribe, and click on your notification buttons for more updates.